This video covers how we can compare fractions, even when they're written in different ways. So when we're comparing fractions, they need to have the same denominator. You'll often hear the words common denominator used, and that just means that they have to be the same. So sometimes when the fractions are given to us, they'll already have common denominators that match. Other times we have to create that for ourselves by making equivalent fractions. So we're using equivalent fractions to help compare fractions. And when we're comparing them, we're going to be using the greater than symbol, less than, or the equal to symbol. So it may be helpful to write these down. This is the greater than symbol. This symbol is the less than symbol. And then we have the equal to symbol, the one we're most familiar with. Okay, so that'll be there for a quick reference. We're comparing the fractions 5/12 and 3/12. You'll see that we have candy bar images here, so we can fill in everything that we need. And there are a total of 12 pieces matching our denominator, the total. And we need to shade in 5 for this side. So we're going to go 1, 2, 3, 4, 5. We've got a full row and then 1. The fraction over here is just 3, so we're only going to shade in 3 of them this time. Because there were 12 total pieces in each fraction or in each image, it's easy for us to compare because they were out of the same amount. It's easy to see that there are more shaded in on this side and all of the pieces are the same size. So we would say that 5/12 is greater than 3/12 because more chocolate is shaded. If we do that for the next one, this time there are 8 of them, but still 12 total. Again, 12 is the denominator for both. So if we shade in 8, and then shade in 6, you can see that there are 2 more shaded in 8/12 than there are 6/12. So again, 8/12 is greater than 6/12 because there's more same-sized pieces of chocolate shaded. If we look at the bottom one, again, the denominator is 12, so it's out of the same amount. This one only has 1 shaded, this one has 2. This time 1 piece, that size is less than 2, so we would say that 1/12 is less than 2. Because they have common denominators, we can use that numerator to compare them. So one skill that we have to be able to do is determine, are they equivalent? Meaning, if they were to be written with common denominators, would that numerator be the exact same? Would they be equal? So the first thing that we need to do is figure out what is the relationship in that denominator. Okay, the denominator is going to take care of everything. How would we get from 3 to 12? Using multiplication. We would have to multiply by 4 because 3 times 4 is 12. If we do that, 3 times 4 gives us 12. And we would do the same thing in the numerator because, again, if we're writing equivalent fractions, the numerator and denominator operation has to match, which it does, and 2 times 4 is equal to 8. Now when we're comparing, we can see that, yes, 8/12, the equivalent fraction to 2/3 is equal to 8/12. That's one option we can do. We can multiply to create a common denominator. And then see if the numerator matches. Or we can simplify this side to see if that works. And if we simplify 8/12, we know that we could divide both of them by 4. And 12 divided by 4 gives us 3, and that matches what we had here. If we do the same thing here, 8 divided by 4 gives us 2, and that also matches, showing that 8/12 is equivalent to 2/3. So we would say yes, they are equivalent. If we look at the bottom one, this time there isn't a nice direct relationship between the denominators. However, it wasn't just the denominators that ended up matching when they were equivalent. It was also the numerators. And we can see here that there's also a direct relationship between the numerators, because we can say 2 multiplied by 2 is equal to 4. So if we multiply the denominator also by 2, that would give us 4/6. Well, now the numerators match, but the denominators are different. So what that means is they are not equivalent. Because when we treated them both the same by multiplying both the numerator and denominator by the same thing, the numerators matched, but the denominators didn't. So they are not equivalent. Okay, so checking to see if they're equivalent, we want to see, are they going to be the exact same value, or can we rewrite them to create the same fraction? Other times, we're just comparing to see which one's bigger, because we maybe know that they aren't going to be the same, or maybe they are going to be the same, but we're not sure. So this is where we're going to be using not just the equal to sign, but also greater than and less than. So if we look at this one, we want to find a common denominator between 6 and 4. And what I mean by that is if we were to list the multiples of each, we want to figure out what's the smallest one that matches. So let's list the multiples of 4 by counting by 4. It would be 4, 8, 12, 16, 20, 24. Those are just some of them, but we're counting by 4. If we do the same thing for 6, we have 6, 12, 18, 24. We want the smallest number because it's easier for us to work with small numbers than big numbers. And we see here that 12 appears for both. We could use 24, and you'll notice that 6 times 4 is equal to 24. So that's 1, but we could also use 12. Either way, it's going to help us compare. So if we use 12 in our denominator, we're going to show what we had to multiply by. Well, to get from 6 to 12, we had to multiply by 2 because it was the second number listed. So we're multiplying this one by 2. If we multiply 6 by 2, we also have to multiply 5 by 2. Because remember, those have to match. We have to treat this fraction equally. So if we multiply 1 by 2, we also have to multiply the other by 2. And 5 times 2 is 10. So now we have to think, if we're using 12 for a common denominator, how do we get from 4 to 12? We know that 4, because it's the third one listed, 4 times 3 is 12. Again, it has to match numerator and denominator. So we're going to multiply this one by 3 as well. Always showing our work, and 3 times 3 is 9. Now that the denominators are the same, we can compare. 10 is greater than, it's bigger than 9, so we're going to use the greater than symbol because 10/12 is greater than 9/12, so that also means that 5/6 is greater than 3/4, our original fractions. You'll notice in this one that if we were to list the multiples of 3, 3, 6, 9, 12, the other denominator shows up. So this time, 9 would be the easiest denominator. Yes, we could multiply 3 times 9 together and use 27, but 9 is going to be the easiest. So in this case, if we're multiplying 3 times 3, because it's the third one listed, that gives us 9. So if we multiply 3 by 3, we also have to multiply the numerator by the same value, which gives us 6. And you'll notice that we already have 6/9. If we're writing an equivalent fraction with a common denominator of 9, we would want to multiply that by 1. That's the only thing that works to keep it the same. So we would multiply the numerator by 1 as well, giving us 6. And you'll see here that with the denominators the same, the numerators are also the same, so that is equal, meaning 2/3 is equal to 6/9. For this one, let's just multiply the denominators together, because that's also one option for us. If we multiply both of them by each other, 5 times 3, that gives us 15. So we're going to say 15 is our common denominator. The 5 we multiplied by 3 to get 15, so we have to multiply that one also by 3. 2 times 3 is 6. 3 was multiplied by the 5, so we show that. 3 times 5 is 15. Double check that it works. If we multiply the numerator, that also gives us 5. Now when we compare 6/15 is bigger, so greater than 5/15. So we use the greater than sign. So that means 2/5 is greater than 1/3. We can do the same thing here. 6 times 7, that'll give us 42 for a denominator. We had to multiply the 6 by 7, so that's what we're going to show in both the numerator and the denominator. 5 times 7 is 35. And then for the 7, to get from 7 to 42, we had to multiply by 6. So we're going to multiply both the numerator and the denominator by 6. That always needs to match. And 3 times 6 is 18. Now when we compare, we can see a big difference between them. 35 is much bigger than 18, so that would be greater than. So 5/6 is greater than 3/7. And we're going to do the same thing down here. One option we can always do when we're trying to compare fractions and create common denominators, meaning that bottom number, is to see if one of them can be multiplied to be the other one. So if you look at the smaller number and list the multiples of the smaller number for 8, you'll notice that one of their multiples, one of 4's multiples, is 8. So that would be the easiest common denominator we can create for ourselves. If we multiply 4 by 2, that gives us that nice common denominator. So we're just going to multiply one of the fractions and create only one equivalent fraction instead. And then from here, we already have common denominators, so I don't have to rewrite this fraction at all. And that may sometimes save you some work. Now when we compare, looking at the numerators, 2 is less than 3, so that means our original fraction, 1/4, is less than 3/8, and that would be our answer. When we look at this one, there are two different options we can do. If we look at the smaller one, we can list the multiples of 3, which would be 3, 6, and we find out that 6 is there. So we could multiply both of those numbers by 2, and that'll give us a common denominator of 4, 6. There you can see that they are equivalent. One other thing we could have done is when we look at the 4 and the 6, both of those are even numbers. And if we have two even numbers, that also means we can divide them both by 2. When we do that, 4 divided by 2 is 2, 6 divided by 2 is 3. So you'll see that if we multiplied, we got 4, 6, which is the same thing as one of our original fractions. And if we divided, We got 2/3, which also matched. So we know whether we multiplied to create an equivalent fraction or we divided the other one, that we have two equivalent fractions because they are the same value. Again, we can always just multiply the denominators together. So we would multiply the 3 times 5, which means we'd also multiply the 2 times 5. And that gives us 10/15. Over here, if we multiply the 5, that would have to be multiplied by 3 to get 15. So we also have to multiply by 3, giving us 3/15. Now when we compare, we can see that 10 is much greater than 3, so 10/15 is greater than 3/15, which also means 2/3, our original fraction, is greater than 1/5. A few more options that we can practice with. But either way, whenever we compare fractions, we need to have a common denominator so that we can compare those numerators. So we're going to create equivalent fractions.